And I've just built the documentation locally, and what we have been looking at in this stream is the Python language reference, specifically the syntax, so the expressions, simple statements, compound statements, top level components, and the full grammar, and adding these.
Oh, cool.
That, yeah, for the simple cases it works. For the more complex cases, it's sometimes more confusing than it should be.
Are those auto-generated?
Yes, they're auto-generated from the grammar. So if you look at the full grammar, we have file is this, and there's optional statements, and then end of file, and the statements are just repeated statement. So in here we get rid of the like we combine these rules into one, basically, to make it more understandable. Does that make sense?
Yeah.
Right, so right now we auto-generate these lines. They're not perfect, but in many cases they're better than, or at least more correct than what's already in the documentation. In more cases they're still confusing. And then the last few weeks we've been generating these diagrams using a diagramming library, so that's pretty new. And since you're the only one here, I guess it's well, I'd be happy if you have any questions you want to ask.
No, I guess I'll just watch. Yeah, this mermaid that you're using or something similar?
No, it's this library called Railroad Diagrams. Where do they have an example? Oh, here's a small example. So you basically create these choice classes and wrap them in a diagram.
Right.
And that's generated by the docs. Now, I don't know what would be interesting to explore for you. What we've been doing here is writing this tool called the docs generator for the grammar parser.
Mm-hmm.
Are you familiar with grammars like this?
Not necessarily, but yeah, just go for it.
All right. So where to start? So Python has a parser which is generated automatically from a file that looks almost like this, but with lots more information, and that would be in python.gram. So this is a file in the Python source, which has rules like this. So here's the file one. So there's the file. This part is basically ignored by the documentation. So is this name. So then we have these statements, and because they're in square brackets, that means they're optional. And then there's the end marker, and then there's this action part that's also ignored. Right. So what that means is if you have a Python file, there might be statements in it, or it might be empty, and the statements then is a sequence of individual statements, and that statement can be, so this line is wrapped, so it can either be a compound statement or simple statements, and so on. Hope that makes sense. So
yeah.
this thing, that's in the current docs also. If you go to the reference to the full grammar specification, so this should be unchanged from what's currently in the docs, and it's a bit cleaner. All the information that doesn't really tell you how Python is parsed is removed. So statement is a compound statement or simple statements. Compound statement, or well, let's look at simple statements. So simple statements, there's either one simple statement followed by a new line, and there cannot be a semicolon before that new line. And as the comment says, this rule is not necessary. In reality, simple statements are semicolons separated. They can be followed by an optional semicolon, and then there's a new line. Does it kind of make sense?
Mm-hmm. Yeah.
So let's look at how we explain it here. So there's statement statement star, which means if you look at the railroad diagram, you can skip it entirely, or you can go through here. That means, you know, there needs to be a statement in the file, and then there's an end marker, or you can take this rail down here and repeat that statement as many times as necessary, and then go to the end of the file. So these railroad diagrams were popularized by, I think, the Pascal language, which had its whole grammar explained in this manner, and it makes it, I guess,
sorry I'm late,
more welcome. Oh, hello, Blaze. So if we then click on the statement, and I do need to make this clickable as well. So statement is either compound or simple statements, and then if you go to simple statements, then you can repeat as many as you want, separated by semicolons. Then you can have a semicolon at the very end of the line, or you don't have to, and then there's the new line. Right, and that simple statement then can be one of lots of things. So that's basically what we were doing, and now we're pretty deep in details, I would guess. Blaze, since you joined, do you have any questions or comments to start?
So no. In other words, I've got some little PRs and things that I'm working on tidying up and some catching up to do. But I do not, other than especially since we're recording this, feel free to point out places where we might build tests, because William and I have been trying to build tests as we go along.
Do you have any work in progress?
No, just that one test that we wrote. I think we have a PR to your repo. I don't know if you looked at that. That we wrote a test. That was a couple of weeks ago. I think you might have approved it already, maybe not.
So my repo is here, and there's...
I think it was to your repo.
Yeah, I guess it's approved. Let's look at the history here. Oh, here it is. Add tests. Test docs generator. All right. Test docs generator. Let's look at that. Yeah, that's the one. So I guess this is the correct place.
Okay.
I'm not sure if peg generator / docs generator is the correct place for this tool, but moving it shouldn't be very hard.
Okay.
Right. So where were we? I don't know if I should explain this whole tool, but as
so maybe
Yep.
ask Melissa, do you have any questions?
No,
Or anything
I'm good.
Anything
Yeah,
you're particularly
I just,
interested in?
sorry, no, I just want to watch. So if you want to work and you have stuff to do, just go for it, and I'll just be watching in the background. If I have any questions, I'll speak up.
yeah, definitely speak
that'd
up.
be great. Yeah, or you can drop it in the chat as well if you're so
Okay.
inclined.
Sure.
Right, so as a general overview, it's a command line tool, so there's an argument parser, there's a lot of to-do comments. The main thing this tool does is create these structure of classes for the nodes, like a choice between two syntax elements, sequence, marking something is optional, repeating it, and so on. And this basically mirrors what's already in Python's parser, but we pretty much need to have our own classes so we can do things like simplify them to make them easier to read. And then this giant function that converts the Python parser nodes to R nodes. And there's a lot of complicated logic to simplify things, which mostly works. Then there's this node to diagram element, so we go from our classes that were just defined to classes in the diagramming library, and that's not very complicated. It's mostly one-to-one correspondence. For gather, we need to use something a bit more complicated. The lookaheads aren't supported by the library at all, so those look pretty weird. And yeah, there's a function to generate diagrams. So if you don't have any questions, one more thing I guess I should say, where you can look at the code, right? So in my repo, there's a branch called Grammar and Docs.
Got it.
That should be up to date. Yeah. And I guess the recent commits. Well, this one added all the pictures, but the docs generator.py, that's the file to look at. Guess I can put this in the chat if I find the chat. Alright. So, if there are no comments, let's look at the to-do here. So one to-do here is do more inlining for the diagrams, because we can preserve the names. So what that means, let's find a nice example. So here, if we have, if you're generating diagrams for eval and expressions, then we could take this diagram for expressions and inline it in here. Hello. We're just getting started reading the to-do from last time. Oh, you're breaking up a bit. Hopefully that wasn't a question. but if you do have a question, please ask. So I guess what to do here would be to count how many times, well, for each of those these top level rules, we can count how many times they appear in the overall diagram. And if something appears exactly once, then we don't generate this thing, but stick it in here. Let's see if I can put that in the code. So here we are actually generating the diagrams one at a time. So there would be two parts to this task. One would be to actually inline things, and the other one would be to the other one would be to omit the ones that aren't needed. So where is this generate diagrams called? So that's just a top level function. It gets top level rule groups. I don't know if that's used. No, it's not used. It's just printed. So let's see what that does. That's this big thing that gets printed at the beginning. No, this one, that's the top level groups. And that tells us that we're documented this compound statement and block together, this if statement and else block together, this while statement, and so on. So I guess what we can do is well, go through each of these groups and see if we can inline something from them. So instead of going through all the rules, right, we're going through all the rules. How many images is this generating? Is it generating too many images here? Should it just go through the top level rules instead? Let's see. If I go for each name and the top level rule names, and then get the node from the rules.
Oh, I see. The top level group is the group with all of its members, and then the top level rule names is just the name of the top level group.
No, the top level rule names is just a, I guess it's a list of all the top level rules.
Oh, okay.
Right?
It's like the table of contents. Yeah.
Pretty much. Basically this thing, but flattened. It doesn't group them.
Okay, I see.
I guess we don't need both of them, but that's what we currently have. So, okay. So what happens if I only do the top level rule names? Is we get rid of, like, this target with star atom, and then I get an error for Sphinx saying that some of the images don't exist.
Really? Okay.
Which is reasonable. Okay, so I do need to do it as it was before. So I do need to generate images for all the rules. And can I use these top level rule groups? No, I don't think I can do that. So what I'll need to do is look at the logic that gives me, gives me expressions here. I don't know if expressions is a top level rule though. Let's see about that. So that would be in top levels, components, and yeah, so here the top level rule is eval, and we generate both eval and expressions.
Okay.
Right. So I guess I need to find the logic that tells me what to generate here, and either reuse it or duplicate it, and that will give me the group of rules to inline inside each other. So where do we do this? It's the generate rule lines. And here it is. Get rules to document. So it's a function. Nice.
That's cool.
So I'm printing these generating lines. And this will give me the rules to document. Each of the rules should be documented at, in one place only. So what I'll do here is I will go through the top level groups after all. Once I have that, I'll have these rules to generate. So get rules to document should take the whole rules, all of the rule names. So those are the ones we're asked to document. And it finds what other ones should be documented, but skips the top level ones which should be documented elsewhere. Perfect. Okay, so rule names is this group. Top level rule names, we get that from here. What's the type? Rule names to generate. Okay, so it will give us the names. So we'll loop for all names in this, and we need to get the node. Corresponding to the name. Hopefully that'll work. That was successful. That should still be the same. And if I look at the diff here, some unused things are gone. So this is expression without invalid, which I guess only appears in invalid rules, so it's skipped. Function type, which presumably is a type annotation, which we don't really document. And literal expression, what is literal expression? literal expressions are used to restrict permitted mapping pattern keys. Huh. It's weird that that isn't documented anywhere. Maybe it was inlined?
You mean a description of the grammar for a literal expression?
Value pattern. It's a literal pattern. We do some. Oh, replaced synonyms. I see. We have a special case here, saying that literal express should be replaced by literal pattern if it is the same. The grammar others will have different actions, which we ignore here. So that makes things a bit more readable, apparently. And that means we don't need to document this one because we use that one in the docs. Okay. And then T look ahead, I guess that only appears in the look aheads, which we don't actually need in the docs. So great, this means we don't document what's unneeded. And now what we can do is start inlining. So what do we do here? We do something similar to the simplify rule set. Basically, we count all the non-terminal terminal nodes. So we have count up all the references to rules we're documenting. So we need to go through all the names, get the node corresponding to each name. We get all the non-terminal nodes recursively. We get the descendant name, non-terminal name. And if that name is in the rules to generate, then we add one to the list or to the like counter how many times it appears, right? So this tells me, hopefully, let me print the reference counts here. So usually there's an empty counter, but sometimes, for example, if I go to patterns.svg, this says that pattern appears. Well, I guess all of these are in the same chunk, something like that. So pattern only appears once in this like group of 3 diagrams, and that means I should be able to inline it. So let's look at how it looks in the documentation. Patterns looks like this, and since pattern only appears here, I should be able to take this and inline it into here. Does that make sense? Or how have I lost everybody?
Oh, sorry, my microphone's off. Yeah, it looks good to me.
So let me do this in this easy way. Rules to inline will be a list of names in these reference counts if the count is exactly equal to 1, right?
Right.
Can I put it on one line? Yeah. Okay. And then I have this node to diagram element, which now will take one more argument. That's the rules to inline. And I'll need to add it to all of these recursive invocations.
Wow, cool.
Should be probably using a class or something. Okay, everything works. But now, oh, there's one more thing I need to pass, which will be all the rules. And I probably will need to add some kind of state object, so I don't need to do this every time I add a new argument. But I'll also pass in the rules. That should still work. No. For the choice. Oh, I missed it here. Right. And now if I have a non-terminal here, I say if name is in the rules to inline, then I'll create an inline diagram, which would be node to diagram element. So this is the railroad library. The node I want is this one. And then I need to pass rules and rules to inline as the state for this whole thing. Right, have fun, whatever you're doing. And then I will return group like this, and the group will be named using the name. Let's see if that works. Maximum recursion depth exceeded. Oh no. Oh dear.
Wow.
That makes sense. If something is recursive, then we don't want to have an infinity mirror. But it's fun to look at one, right?
Yeah, it is fun. Yes. Oh, yeah. Oh.
So let's add depth to every recursive invocation. So here depth would be 0, and then we will have depth plus 1 everywhere, just to see how it'll work. We're definitely passing too many arguments here.
That basically reduces it to a single iteration.
Well, let's reduce it to 5 iterations.
Okay.
Right, so how does that work now? Right, so pattern here was inlined, so you can see we took this and added it in here instead of you know, doing it directly. So that's like a sketch of how it'll work. The other thing we'll need to do is get rid of this in the generated source. So we'll need to basically combine the image generation with the RST generation a bit more. But maybe let's look at some of the recursions. I guess some should be here. Oh? Where did we get recursion? Wow, this one is so horribly long now. So it's not always a win to inline these decorators and especially these parameters in the function definition. So we'll need to do something with that. But I don't see any recursion. So I guess if I increase this limit here, I should get a diff. I got a diff in the try statement. Let's look at the try statement.
Oh, this whole automation is already working. Okay, I thought it was dummy project, not the real thing. That's nice.
What dummy project?
Yeah, man. It's showtime.
You were just trying on a single document instead of the whole thing, but no, it's actually working.
Yeah, it's we have all the diagrams. Some of them are very confusing now that we've inlined parameters into function definitions, but mostly it works. So try statement. Ah, there we go. I didn't refresh, but no, this doesn't look like there was any recursion here. There's except block, there's except star block. So we'll also change this target with star atom. Which I don't know where it is. Probably not. Oh, target with star atom. What actually changed here? Not much. I thought some of this would get much bigger. Let's see, lambda params. So lambda would be an expressions like, right? Lambda params is just big. I don't know what changed from before. Oh, I didn't refresh, did I?
They look really cool.
I guess it inlined more stuff? I don't know. Where do we get this recursion error anyway? In primary, in T primary, so in the one we're ignoring. Okay, yeah, it says inline one into the other here. Well, I don't think we're gonna. We can get rid of the recursion, but 10 inlines should be enough for everybody, right?
Yeah.
Wow.
Well, even one should
Isn't that
be
amazing?
even one should be enough for everybody. And if you have like one name inside another one, it's not that pretty. All right. Well, but you know, things work now, which is great. Maybe we can look at some more. So compare up bitwise or pair here is now inlined, which is good. Oh, here's the recursion.
Oh, shift expressions.
So shift expressions.
Oh.
Oh, it only recurs twice because it's in a bunch of other elements. Let me only do this depth +1 if we're actually inlining things. So with this,
Oh, you have a plus. Oh, one. Okay.
so now, yeah, now it's proper recursion. So that, yeah, that's just for fun.
That's great. That's really cute.
Well, you can always skip it, right? Otherwise, it would be
You
no
should
fun.
save that. That's kind of cute. It could
Where should I save
be
it?
useful. Oh, I don't know, just local disk or something, or post it on Mastodon. I
Oh,
don't know.
well, it's on YouTube. Anybody can look at it.
Oh, that's true. That's true.
I could, you know, I know where I'll
No.
save it.
Oh.
Well, it's not
That's
11.
great.
It's 10, right? There we go. All right, so
Yeah, really. That's great.
so instead of that, instead of depth, what we really should do here is keep a memo. and a memo would initially be a set. And what we do here is we check if the name is not in the memo, and we add it. Memo. So we say that you know, this particular name should not be added recursively anymore. So that now will only give us one recursion, and I think if something is like directly including itself, this is still too much. So we don't start with an empty set, but with name itself. Right, so now shift expression, you know, this is itself, this is shift expression, but it doesn't recurse into itself. All right, so that was a bit of fun. So I guess the thing to do now is to remove this thing. So how do we do that? Maybe maybe this calculation in here should be done before we generate, well, definitely it should be done before we generate diagrams. And then we pretty much know all the rules to inline. So we're going through the top level groups. And each rule should only appear once in the whole documentation. So for all these generate all descendants, each of the rules, each of these descendants. No, for all of these rules to generate, that's it. If you get the rules to document, all these rules should be distinct. So there's only one place where we inline something. So let's do this calculation a bit ahead of time, and then we save up all the names of the rules to inline. And we don't generate diagrams for all of them, and we pass them as is to this node to diagram element. Don't know if that makes any sense. So new function here, and that should take the rules. It also needs to take the top level groups and top level rule names. That should be it. And then it creates one, I guess it can be a set. Adds things to the set. And there we go. And it shouldn't be reals to inline, but rule names to inline, which I'll just call result. Right? So now we call this somewhere. Grammar. Where are we simplifying things? Is it already in like generate rule lines? No, things should be already simplified here. Convert grammar. Yeah, this one simplifies stuff. So after convert grammar, we get the rule names to inline. And do we have all the information here? So we have rules, top level groups. Top level rule groups. Yep. And top level rule names. That's this. Okay. And then I guess we need to pass this thing to generate rule lines. Everything's getting too many arguments. Aha. There's one more complication here. Which is whatever we're doing here is actually done in the Sphinx extension, which is quite specific, I think. Yeah, this one. So the grammar snippet directive here
Oh, I see. This is for your production list thing.
Yeah, this converts stuff to production list, and it basically puts everything in the production list. So I guess we need to generate an option for this production list. That's it. How does this work?
Wow, boys and girls, this is where the magic happens.
All right, so yeah, there's we're appending lines here, right? So we've already added the header. And now these two things are adding the options. that get written in here. So these two, and then there's a new line, and then generate rule lines generates basically that, and this indents it. So what we'll need to do is add these to generate rule lines. So we'll yield this. Don't have to do the new line, don't have to do the indent. And same here. And then we'll yield well, the empty string. Get rid of the indent. And one more thing, if the new line is empty, then we don't indent it. Here we just bend an empty new line. Hopefully that'll work. Nothing changed. Nice. But what we can do now is add a new option. Is rule names to inline, so we need to get the rule names we're supposed to document in here, and these are rule names to inline in the diagrams, so we omit them. Now first we can test if this works and put something like diagrams. Okay, and we get this diagram option everywhere. And now Sphinx, of course, raises an error because it doesn't know what to do with that option. So let's go to the extension. There's an option spec. We add diagrams here. And then instead of these rule names, we use the diagrams. How do you get, oh, here's options. So we get diagrams and we split that. Okay. Hopefully that'll work. But now instead of all the rule names, we need to exclude the rule names to inline. So this would be, you know, I would take a set of the rule names and exclude these normally. But what I need to do here is preserve the order. So this needs to be something like a generator expression, or each name in the rule names, if the name is not in these rule names to inline, and maybe I want to ensure that it's a set. I don't know if it is. Get more readable. think I also need to. Okay, let's look at these expressions. I don't think that updated. Oh. Nice, so there probably used to be a named expression diagram in here, now there's no diagram. This one didn't get inlined. There used to be a double start key value pair here, but now it's not there. We have dict and dict comp, but we don't have key value pair. Yeah, that's a problem. Why? Because we need to start off with rule names to generate, not with all the rule names we're asked to document. Right, so we need to take this one and use it here. And I think this will also need. Oh, that changed this file, so that should be fine. Okay. There we go. Alright, so now double start key value pair got inlined, disappeared from here as it should. Dict comp. I guess that's. Yeah, that's something extra. There's key pair, which did not get inlined because it appears in two places, and that would be awkward. And maybe it should be inlined as well. Maybe, who knows? Where do we have some more examples of inlining? Args. Okay, args. Got inlined successfully. This one we were looking at earlier. So I think we should use a different background color or something for these to make it more distinct from the lines. But that's styling for later. I'm not sure if I'm happy with inlining this conjunction. Maybe this inversion should be inlined as well, even though it includes itself.
You mean have it all in one diagram, or have...
Yeah.
Okay, sure.
You think that would work?
So basically, disjunction.
So maybe we should even do something like, if we're inlining stuff like that, maybe we should name everything. So here we would have the group.
Yeah, there you go. And then you can have the variations, the permutations of the group.
Okay, so now we're saying this whole thing is a disjunction, and these ends are kind of extra here, though. And then we can get rid of this text up here. But maybe it's a bit too busy.
Yeah, it does look a little bit busy. Disjunction is or, conjunction is and what's an inversion again?
Not.
Oh, it's not. It's the opposite. Right.
Yeah. So let's not do this. If we switch to a custom diagrammic library, we should do that instead of the names up here. But we don't have that yet. Okay, there we go. Yeah, now, well, disjunction and conjunction seem like they're equally important, right? So this inlining maybe isn't that good, but I guess I can live with it. What happened here? So lambda slash with default got inlined into lambda params and made it too big. How do you know if something, how do you know that something's too big?
Let's see. I guess honestly, it almost feels like there should be just like one path or two. Having three seems a little bit much. You know how when you start?
Mm-hmm. Oh yeah, that's another problem. Well, I mean, these parameters are just complicated.
Right. Yeah, these are...
It's nice that we were able to inline that. So and inside this, lambda slash with default is actually pretty straightforward. That's like if you zoom out this little part, I mean, it can be a name, comma, or not. Name default, comma, or end. And there needs to be a slash and then a comma or this look ahead thing. Okay, so we increased the complexity of something that's already too complex to take in at a glance. I guess that's fine. Tuple with its star named expressions. Yeah, this is too complicated. I mean, this is more complicated than it should be just because there's a required comma here. And if we could have a line that goes from here and into here, into here, that would be better, but we don't. Yeah, the first comma is required. All the other ones are optional. I don't think you can really draw this in a better way. Maybe instead of here, go from here. And the problem then is that we have two star named expressions and we can't really inline this into both of them, which I guess is a reasonable choice. Okay, that's expressions. Let's see what happened in simple statements. So simple statements got inlined. This is nice and compact. I really like this inlining here. Do you agree?
Yeah, it's very digestible, like at a glance.
I just wish we had a better way for this gather with an optional separator at the end. I mean, yeah, that requires a custom diagramming library though. The simplification rule for it wouldn't be that that bad to write, but I don't think we can model it in with the library we have. And also in the text, this is probably the best way we can have it. Star expression. This is a bit busier, but no, not that bad. This annotated right hand side. I don't know why it wasn't inlined in here as well. It's probably referred to somewhere else. Oh, but this is good.
Annotated meaning like for a typed annotation?
Well, I think something else. Oh, f-string replacement field refers to an annotated right-hand side. So this needs to be like a link target. Something needs to link to here. And if it was buried somewhere here, well, yeah, the problem is we can't really name things in here. That would be way too busy for text. The name here is fine. Could be a bit more prominent. Right, what do we have here? Star atom and star target's tuple sequence got inlined into here. And I don't know why star target didn't get inlined into it. Oh, it's because it appears in here as well. So it's probably good that it didn't get inlined. It does need its own definition here. Why is this that complicated? Single subscript attribute target. Why is it on its own line? It probably needs to be split. You probably need to explain this thing and then the next thing, so on. Right, augmented assignment statements. This August sign. Maybe that should be somewhere up here. So where does this appear? Here. Yeah, it'd be nice to inline that. Let's see if we can do that. So that's simple statements. And maybe we could take this aug assigned and delete it from here and put it up here. Oh, is it the only place that it occurs? Yes. Ooh. You should have got inlined without a name, which doesn't look very nice in the text. So I'll do one more thing, and that's put it in here. And that should only inline it in the diagram with the name. Yep. How do you like this?
Well, I mean, it's clear.
It's much clearer than the name, I guess.
Yeah. The dotted line thing helps, because then you can tell it's just like the eye just kind of scans down.
Yeah.
It would jump over it.
Right, so that is good.
Yeah.
Went through this. Augmented assignment doesn't now have syntax. Assert statement, nothing to inline there. Delete statement, nothing to inline there. Where's T primary? Why do we not have diagrams for T primary? Oh, they refer to one another. Huh. Okay. There's a problem here. We don't get any diagram here at all. And why is that? Because the primary would have been recursively inlined into itself, but the piece of code that does that doesn't take this into account. Right, so we do node to diagram element, and we have these rules to inline, which maybe generate diagrams could take these, since we already computed them, which wouldn't really help much. but we got rid of some of the duplicate computation. Yeah, so the problem here is that we're saying primary should be inlined into itself, and then we're skipping everything that would be inlined. Right? Does that make sense? I'm not sure if anybody's following me at this point. Are you still there?
Yeah, I'm trying to make sense of it. I would say, now what is T primary? That's the...
So
in other words, T primary doesn't appear in primary, does it? Or
no. So let's put them beside each other.
Oh, that's interesting. Way to compare them.
Oh, and the Chinex would be right here. So the difference here is that slices got moved from here to here.
Okay. So, okay.
And this, right? And so a generator expression, I don't think that can start with this. So primary and T primary are just an optimization.
I see, okay.
So they're basically exactly the same thing. I would be tempted to put them in the newly rediscovered replaced synonyms.
Right. Okay.
But
is the same as... Okay.
But I don't think this will actually work because they are different. And we don't have the logic to tell that they're the same.
Okay.
Like when we compare stuff, we take the order into account. So maybe we need a way to, force this just for the reader. But yeah, they're the same thing, which should be clear from the diagram that we're not generating. But why are we not generating the diagram? So if I look at this, slices here got expression inlined inside it. Oh, that's interesting. This expression doesn't even appear in here. Oh, there. See another bug. Expression should probably... Yeah, expression shouldn't be inlined at all, I guess. But anyway, what happened here is that expression was inlined in here and it wouldn't appear in the documentation. Let me find a better example. Do we have any example of inlining here. Oh, this is worse than I thought. Expressions maybe. Oh, here we go. So double start key value pair here got inlined, and the diagram for that doesn't appear in these diagrams, right? It's already in here, so we don't need to generate the diagram for it. But for the primaries, we say, you know, primary should get inlined in this place, but then we don't generate the diagram because the diagram is included in that. So the fix for that would be to handle the recursion, basically. So the same way we handle recursion here in the node to diagram element, we don't need to handle the recursion in wherever we get the rule names to inline. That's here. And I guess we can eliminate one level of the recursion if we just check if the non-terminal name doesn't match the name of the rule we're currently looking at, which would be this case, so this primary for that primary, and that'll give us the diagrams here. Does that make sense?
Yeah, I think so.
Yeah. And then the other thing I was looking at, we probably only want to inline the things that we are skipping. So where did I see that? Where did I see the mess? Here, named expression. Should we inline the named expression in here? Or keep it as named expression, which eventually will be a link to here?
Slice. That's inlined, right?
This is inlined. Well, it's inlined because it's only inlined because it was inlined in the place it was defined. Right, so there's a global flag that says, you know, named expression should be inlined, and then every time it appears, it gets inlined. It's not what I was going for. So maybe the things we should inline are only the elements of the group we're trying to document, like these rules to generate, right? Rules to inline would be rules to generate, or rule names to inline intersected with the rules to generate, right?
Yeah. Rules to inline, rules to generate. Yeah.
So then instead of memo here, we'll get what's the name? Rules to inline. Oops. Oh, and I guess we only need one argument now. Does that make things better?
Yeah, it kind of does actually.
Yeah.
Yeah.
So now this named expression is left here. Can't click on this, but if I click on this, I get to its definition. Yeah, that does look better, yeah. And hopefully we didn't break anything else. Right, so args gets inlined in here. Anything else that needs args, I'll just link to here. Find some. Maybe this should be swapped. Some expressions. That's better. This actually looks very nice.
Yeah, it does.
I don't know about this, term referring back to itself like this. That's an interesting case.
So a term can include a term.
Right. I don't know how to better draw this. It's yeah, I guess this grammar wasn't really made for railroad diagrams. If you try to follow this as a railroad, it gets mind-bending. But is there a better way to draw this as a railroad diagram?
I don't really know. I mean,
how does the
somebody who's
how does the Pascal diagram do expressions?
Also, I think JavaScript does this as well.
Oh, right. Or JSON. Oh, JSON doesn't do. Now, does JavaScript have a poster like this?
Oh, I know. I seem to remember Doug Crockford had railroad diagrams in one of his books.
Oh, there we go. There's factor here, which refers back to itself. So this does have expressions. This does have recursion. And of course, expression here can be a simple expression, which can be a term, which can be a factor. So there's like more complicated recursion in here. So that works. And I think if we style this better, like if we make it very obvious that this whole thing and this part of it is a definition of the rule named like that, it'll be more obvious. But of course we can't do that with this library. But here everything got inlined and it's recursive, but looks fine. Let's compare up bitwise pair. Got inlined, which is great. Here everything got inlined this time. Nice. So inversion refers back to itself. Why not? And of course lambda params is complicated as ever. Yeah, I think we're good. Delete statement got its target in here, and this didn't get inline because it gets repeated here. It's fine. Import from targets got inlined here, which probably makes the whole diagram longer than it should be.
Maybe we should have import from targets as a separate.
Yeah, but I mean, we could do that.
I don't know.
Right.
I mean, I know we sort of do, but import statement, import from. I guess maybe it doesn't really matter.
Oh, yeah, it doesn't matter. So I guess the main thing to simplify here is this part, which says, you know, you can have the dots or the dotted name in this order, and you need to have one of them. Which would be a case for this optional sequence, except it's not really optional. Oh, this is where every item is individually optional. Ah. You need need to have at least one of them. Probably there's a way to draw that. If we add a line from here to the end. It's a bit similar to this. Anyway. Yeah, this aligning isn't great, but it works. Now for compound statements. Elif got inlined in here, which again makes things wider, but that might not be a problem. Except block and except star block got inlined in here. In the try, which is probably good. Now with statement. Nothing got inlined there. In match we, too much inlining here makes things too complicated. Although if after this new line we actually added a new line, that would make things easier to read. Pattern got inlined here, that's great. Signed number and complex number got inlined here, that's perfect, I would say. Adder got inlined in here, which should. What is this line doing here anyway? Let me add that in to do. There's no reason to have a value pattern rule, is there? And value pattern is defined as adder with a look ahead. So yeah, it's this look ahead is not important there.
Okay.
Apparently we got rid of it. So we can remove this line as well. Let me add this in here. So we want, instead of value pattern, we want to say adder. But I don't think the logic for synonyms will catch this. Because one is just a reference for the other.
Oh.
So there's small to do here. open sequence pattern is probably good to have inlined. The same for star pattern. Yeah, most of these inlines are a good thing to have. But at least one can be chosen. Yeah, we have the same thing here where this pattern is optional and this keyword patterns is optional, but you need to choose at least one of them, and there needs to be a comma between them. Function definition, yeah, this is inlined too much. The whole parameters thing got inlined into function definitions, and that's just too much information. But again, if we broke the line in the proper places, it wouldn't be that bad. Type param here is probably a good thing to have.
I've been making some bread while we do this.
And I didn't think. Oh, we inline expressions side here. That's good. Right, so I think this this was successful. Let me commit it. Inline. And I have 6 minutes left, so I don't think it makes too much sense to do much else. Maybe this value pattern, maybe there's enough time for that. So we need to get rid of value patterns, so it replaced synonyms. So there's simplification. Right, so if my rule is exactly the other rule, then we replace this non-terminal with the other one. And I guess if my rule is non-terminal, that only contains the other rule name, then we replace self with the other rule name. Will that work? So what did that do? It replaced value pattern with adder. But we're still documenting value pattern. Why? Is it in the top level rule names? Yeah. What if I remove it from here? Oh, things break? No. Oh, great. So now value pattern got replaced with adder. We got rid of the definition and got rid of the image for it, and things still work. Great. Maybe we could do that for more things. Like, are there any rules that are just synonyms? I don't think there are too many of those.
Wow, it's looking really good.
Yeah. Right, so let me...
That's cool.
Oh, one more thing I need to do is get rid of the to-do notes once this is done. And I'll push it. We can play around with it if you want. And I guess that's it. Thanks for your attention and see you next week.